Hey everybody, this is Mr. Walsh, and we are going to finish up our discussion on the mole. And in this case, we're going to be just talking about molar mass. Okay, that's the important thing, molar mass. So we're going to calculate it. In the last video, we talked a little bit about where it comes from and what it is, but now we're going to calculate it, and that's going to be the skill that we're going to want you to know. So this is how this works. Okay. Is that if we have the molar mass, we're going to add up the mass of all the atoms in a formula. So if we have CH4, okay, we have one C and four H's, and we know that from the periodic table, carbon has a mass of 12.01. And so we're going to multiply 1 times that, and then we're going to multiply 4 times 1.008, and then we're going to add those two together. Okay, so this gets to be 4.032, this is 12.01, and so I did this, and so what we know is that because this compound is a gas, we could go back to last unit, we could do the Lewis-Dot structure of this. Okay, this is a gas, okay, it's nonpolar. And so we know that 1 mole of this is 22.4 liters. But we also know that 1 mole of this has a mass of 16.042 grams. So if we have a problem like this, calculate the molar mass. Here's the way I would do this. I would list the elements, A, L, O, and then I would say, how many aluminums are there? There's 2. How many O's are there? 3. And then we're going to use our periodic table to look up what the mass of aluminum is. And so we get that the mass of aluminum is 26.982, and oxygen, the mass of oxygen is 15.999. Okay, and if your periodic table is a little bit different, that's okay. Carry it through. Use all the decimal places that you can. Okay, on the periodic table. And so now we're going to do some math. So again, we take out our calculator. Okay, and so now I'm going to do the math here. So I'm going to do 2 times 26.982, and that's going to be 53.964, and I'm going to do 3 times 15.999, and that's 47.997, and then I'm going to take those two and I'm going to add them up. So plus 53.964, and I get 101.961. Now the important thing is to make sure that we have the right units on this. This many grams equals 1 mole. Okay, that's what it is. We can rewrite that if we want to as grams per mole, but for now we're going to use this because I think that this is going to help us do the next section. So now we have parentheses. Okay, what parentheses mean is that we distribute the number. This means that this formula is MgNO3, but there's 2 of everything, so there's 2 NO3s here. So if we're counting, there's 1 Mg, and then there's N. N could distribute here. 1 times 2 is 2. Or if you count here, there's 2. And then O, that's 2 times 3 is 6. 6. Okay. And then we look at the periodic table. What is the mass of magnesium? Okay. Now, at some point, you're going to memorize probably a lot of these. So, but if you look, magnesium has 24.305. Nitrogen is 14.007, and oxygen, we just did from the last one, so I know is 15.999. Okay, and so now we're going to add them up. Okay, 24 28.305, and this is 28.014, and then I'll do this one here. Okay, 6 times 15.999. Oops. 6 times 15.999. We get 95.994. We take these and we add them all up. Plus 24.305 plus 28.1. Oops. 014. We get 148.313 grams equals 1 mole. So what we're saying is 6.02 times 10 to the 23rd molecules of this compound is going to equal 148.313 grams. Okay? What this does is it gives us an easy way for us to kind of visualize a specific quantity of this compound. Okay? And this is an ionic compound. Okay, you know, because it's got a metal, it's got some nonmetals, and so this is a solid. Okay, and that gives us insight into this compound. Okay, so same thing. K, O, we have 2 Ks and 1 O. And so now let's figure out what the mass of K is. K is right here. Okay, so we get 39.098 and 15.99. Look, we've done 3 problems, and all 3 of these problems have an oxygen in them. Okay, you can't get away from oxygen. Okay, so now we do the math. Okay, so 2 times 39. Not 2 decimal points. Okay. 098. So it's 78.196. 15.999. Okay, so that's plus 15.999. And we get, oh, I multiplied. I'll leave the mistakes in because, listen, I make mistakes too. It's fine. So let's do this again. 78.196 plus 15.999. That's 94.195 grams equals 1 mole. So look, oxygen again. At this point, you should have memorized oxygen. You don't have to, but again, you just use it so much that that's what happens. P, there's 2, O, there's 5, 2 times, 5 times. So we look at the periodic table. Phosphorus is 30.974. 30.974 is 15.999. Okay, so 2 times 30.974 is 61.948, and then 5 times 15.999 is 79.995, and now we are going to add these two together. So 79.995 plus 61.948, we get 141.943 grams equals 1 mole. Or if you wanted to, 141.943 grams, symbol for grams, divided by mole. Okay? Either one is going to get you right. So that's how you calculate molar mass. That's the skill that we're going to use a lot here because the calculations are going to be the thing that we're going to be focusing on. Okay? So there you go. Have a great day, everybody.